but otherwise. Can everybody see me? Hello, how many people are here? Only one participant? Okay, everybody's supposed to check the email, so. Let's. Just a moment. Oh, the 12 people. So how do I have people enter the waiting room? Huh?
They're waiting to click view at the top.
How do I, I click view. Okay. So that's them in when I do that. So, admit all, okay. So next time I'll turn it off. Hello, can everybody hear me? Can people hear me? Can you hear me? Hello?
Yes.
Okay, looks like we have 12 people here. Good. All right, wonderful. Okay, so what we'll do is start. I'm going to be wandering around in front of the board. I will write on here. Okay, I will write on the board here so you can see it when I do that. Otherwise, I'll be using the PowerPoint. Okay, so can you folks? Can you see my writing on the board there? Can
Yes.
you see my writing on the board there?
Yeah, we can see it.
Yes.
Okay, great. All right, wonderful. I'll be using this and then I'll switch to the PowerPoint and then you can see how I do it and I'll draw on the screen. So basically that'll cover what we're doing. But right now I'm gonna kind of talk to the class here and then you'll see me in person on tomorrow. Okay, now basically this is General Chemistry 1. My name is Dr. Douglas. As I said before, I grew up near Philadelphia, Pennsylvania. I don't have much of an accent. One thing you'll notice is I do have an accent regarding how I pronounce one word. Anybody have any idea? Well, I might have said it last time. Well, it's just the way I pronounce water. Okay? That's a local accent just around the suburbs of Philadelphia. Okay? It's something a friend of mine at North Dakota State noticed shortly after I got there. She printed out. It was amazing. I didn't even know I had an accent. But in any case, I grew up in the Philadelphia area, so I have the typical Middle Eastern one as well. And so basically, my accent doesn't change wherever I've taught in the world, so it's like it's kind of things. But basically, I've liked chemistry for a long time, and so it's a situation where we basically are now. Okay, basically the key thing is that the key thing to understand regarding how this class works is the first thing we're going to do is introduce you to the topic of chemistry, what it is and such like that. And basically I'll start off with mine. Chemistry is the study of matter. Okay, and matter is anything that occupies space and quantity. In other words, occupy space means what? What does occupy space mean?
Space.
Yes, so it has measurements associated with it. What are those measurements? Length, width, and height. So basically you got length, width, and height, and quantity, and this would be a number. And obviously it starts with number 1, and number 1 is defined. The number 1 is a fact. It was defined years ago, but it's just like the finger number 1, just one finger. Okay, and it's fundamental to all sciences. And the math rules, 1 plus 1 is defined as being true. That is a fact because of the definition of what 2 is. Okay, so basically we're dealing with objective truth because general people have decided we're going to follow convention and come up with standard things because it's defined as being true. So what we're dealing with now is the nature of what truth is. And one of the fundamental things of philosophy is that, good grief. Basically, one of the fundamental things about philosophy is that is basically, I think, therefore I am. In other words, we're not living in an illusion or part of a simulation. It's something that we observe is real. We can observe things with our senses, our 5 senses, whether it be scent, smell, taste, feeling, seeing, or hearing, okay? So again, the thing is, we observe real things. Okay, so now I'll make a presentation and get that done here. Pardon me while I set this up. Okay, I'm going to go to PowerPoint right now. Pardon me, I'm trying to get this set up here. Okay, those of you on the thing, can you see the slideshow?
No, sir.
Okay, hold on a minute. Can you see the slideshow now?
Yes, I can see.
Yes. Yes.
Good, wonderful. Okay, so now we can go with it. Okay, so basically here, there's different examples here of different things related to it, and they kind of start off with chemical tools, but I want to talk about in general the nature of what the, I think I'll go back to the thing, but basically the study of matter and matter occupies space. Essentially, you have got quantity associated with this and observations. So there has to be chemical tools involved in this. So basically, there's a variety of different things regarding things like nanoscience and fuel cells and such like that. But nanoscience is essentially, sorry, I gotta change the pen here. Okay, nanoscience is essentially dealing with I don't know why the pen won't work. Just a moment. Okay, here we're dealing with various things regarding nanoscience is essentially about small things. Okay, can everybody see what I'm doing now on the screen? Can you see what I'm doing? Very good. Okay, and basically these are between 1 and 100 nanometers associated with this. You folks can see the screen up there, right? Okay, so basically nanoscience is a very big thing. In a way, I think it's overrated because basically it's just another name for microscopic looking at things, okay? Please don't, I don't know why scientists invent these tools other than kind of making it more important than it is. But there are various things that have relation to this regarding fuel cells and other things like that to generate hydrogen, and we'll be learning how they are used eventually. So basically what we're dealing with essentially is when you're talking about things, we got all these things regarding observations has to do with what is called the scientific method. And this is on the PowerPoint as well, but I'm going to show you on this things. So essentially the scientific method is important. Okay, it starts with observations. Okay, what is happening? What? Okay, now imagine you're a caveman. Okay, you just came out of the blue and you saw lightning hit a tree and it caught on fire. What might an interested caveman do? Huh? Well, try, okay, but first thing they'll do is ask why. First, what's happening and why is it happening? Okay, so essentially asking why is a very important aspect. First, they see what, then they ask why. And then they come up with a hypothesis, which is an educated guess. Now, the book that I gave you assigned for chapter 1 to 3 goes into this more detail, okay? This book that we're using assumes you already had high school chemistry, so you understand this. But it's very useful to go over this again. So essentially, this is an educated guess. Now, the caveman might have saw the lightning hit the tree, and then they ask the question, why? Well, then they come up with an educated guess or a possible explanation. Well, the lightning hit the tree, so basically it caught on fire, okay? And then they noticed it was burning, and so then they took a branch off of it and lit something else on fire, okay? So they tried a little experiment. Pardon my things here, but essentially they ask the questions why here first. Then they do a test to change one variable at a time, to take a lit stick and then light something else with it, okay? So they test it. And then they explain the experiment and they describe fire, okay? And that predicts future outcome. Okay, so essentially you have this, the experiment, it's a test, and then you have a tested hypothesis. Okay, and basically we have this here, which is a tested hypothesis. And pardon my handwriting, but it'll make more sense if you listen to this while you do it. Okay, and basically the tested hypothesis is called a theory. Now, I've got a question for you. Is a theory a fact? No. All it is a tested hypothesis. If something has been tested 1 million times, does that make it a fact or does that make it fundamentally true? No, it just makes it for it to be accepted as true. The accepted as true is a thing of belief, okay? And there's an extra step past this, and it's very, very important to understand that when you have theories, there's what's called objective truth, which is something that's defined as true, or something that's defined as true, or that is true. Okay, it was created by someone who made something, like someone makes a cake, they have a cake there in front of them. That's true, that's fundamental. That's objectively true. Any observer can see the cake. Well, if you go to the position of God creating everything, that is objectively true. That's what we believe, okay? But again, it's a matter of belief that goes from possibly true, which is a theory, to objectively true. So there's what's known as subjective truth. And the subjective truth is based on beliefs. Now, if I put a fried egg on my shoulder and say, that gives me great peace and joy, that this fried egg is on my shoulder, does that make it true for everybody? No. Okay. So essentially, it's just a belief that I might have that might be a bit strange, but I'm not saying I do. But the point is, again, it's a belief. So normal people, when you have theories, they can be accepted as fact because they believe it to be so, or it's a matter of faith. Okay, like for example, when you go out of your dorm room or out of your dorm in the morning, you have faith that an airplane flying over will not drop something, a wheel from it, and then fall on your head. Is that a possibility that might happen when you walk out? Yes, of course. But you believe it won't, okay? So we make beliefs and statements of faith all along, okay? So again, if we have subjective truth, we have beliefs, but it doesn't make it objectively true. Now, this happens to be a Presbyterian college, which is based on the historic Presbyterian denomination, which has its standards of Westminster Confession of Faith, of which some of you are familiar. One of the phases in there, and I'll talk about it tomorrow, is that basically one of the things is that God created the heavens and the earth, and that basically God knew what he was doing and designed it such way, okay? And it's a really interesting passage in the Westminster Confession of Faith, and it's true that all the different Presbyterian denominations aspire to it, okay? So again, theories of evolution, does that make it an evolution the way some scientist or an atheist scientist believes it? Does that make it true? No, okay? It's a belief, it's things. If you've got 1,000 scientists that they say they believe in evolution, that just means 1,000 scientists believe in evolution. They could be atheists, or they could be Christians, nominal or believing ones, or whatever else. But I happen to believe that basically God created the heavens and the earth and gave us brains so that we can observe it and interpret it. And observing means you're going through the scientific method. You're asking, you observe something, you ask why it goes through. It's like a child learning how to talk, walk, etc. else. Okay? They make different steps to faith. They assume it works. And so eventually a little girl who's crawling in the thing, I have two twin granddaughters, age 3. So I kind of saw them grow up, crawling. Eventually they get faith enough to run around. But that takes one step at a time. But basically you got steps of faith all along here. And so basically if we start with the fact that subjective truth is a matter of beliefs that could be true or might not be, and they're usually based on theories. Is the theories of evolution, is it valid? Sure, why not? Okay, but the Bible kind of summarizes it in Genesis chapters 1 and 2, and essentially gives an outline. Does it say that the earth was created 4004 BC in Genesis 1 through 6? No. It says there were 7 days, the seventh day he rested. It doesn't even say they're little 24-hour days, even though the words might indicate it. That's a matter of belief. But if Adam and Eve were created in the 6th day, does it matter what the timing God chose before Adam and Eve were created? Whether they were 24-hour days or billions of years? No. But the point is God created everything, so we can observe it and whatever else. Now that's known as general revelation, okay? Special revelation is stuff that comes from the Bible regarding theology, other stuff like that, regarding what a Christian believes and such. But general revelation is truth that's revealed to everybody and can be observed and whatever else, and that's what scientists. And it doesn't matter whether they're atheists, agnostics, Buddhists, or whatever else, they can all observe the world. Buddhism is a problem because some Buddhists believe that everything is illusion. And if everything is illusion, everything is subjective. And so they could get very brutal because basically they just, whether they treat someone badly or whatever, it doesn't matter. It's all part of a simulation or a thing. But again, we're dealing with subjective truth there. So what I want you all to understand as budding scientists is facts are anything defined as true, okay, like 1, the concept of 1 and 1 plus 1 equals 2, okay? Or what hydrogen is the letter H, because it's been defined as having the letter H, okay? Helium, is that H? No, it's He. It's defined that way, okay? So again, it's a matter of definitions like this, names like this are used by people all over the world, and it doesn't matter what culture or whatever else, to communicate with one another. Now, one of the things that's interesting is when I started college, German was a major language in chemistry because a lot of research had been done in German. So I was required to take 2 years of German in college. I got C every semester. I hated it. Okay. over the years since the late 70s, English has been more the accepted language of chemistry and other sciences all over the world. Was it because the American system is more superior? No, it's because different people learned English for different reasons and it got generally accepted as such. Okay, so in some respects, there's nothing ethnic or anything about it. It's just a matter of people realized to learn to communicate with other chemists, physicists, or whatever else, they needed to have a common language. So they decided, well, they go with English because there's British English and it's empire, and there's American English and its influences, et cetera else. And so basically, that's the thing. It's interesting. When I was in Kazakhstan, I had a lot of British colleagues, and they were amused by my, as well as my Kazakh students were interested in how I learned how I spoke American English, which has different words, different spellings, and everything else. But they got used to it, and I think they liked it, because one of the things about Americans is there's not really a stuffy class system. Okay, some of your parents might be very, very wealthy, but in general, most of your students won't care. You sleep in the same dorm rooms, you eat the same food, you're just normal people, just like everybody else. And yet in Britain, they have their own schools, they have a caste system. Now, does anybody know anybody from India? Well, India has its own caste system, and that's one reason Indians were very appreciative of the British caste system, because they have the top people, the Brahmin, and then the middle group, and then the untouchables at the bottom, okay? And there's something very, very bad about that. It's tribal, it's even racist, so to speak, because of the different cultures in there too. But the point is, the British have their own class system or whatever else. And a lot of Americans, and particularly the Scots, got kicked out of the UK because of their annoying of the English. And so the Scots and the Irish and others. So a lot came to America, and in a way, I'm kind of proud of the fact that my Puritan relatives were kicked out of England in 1700s on the Mayflower and such like that. And the Quakers also were annoying in another way. So in a way, it's kind of amusing. But the point is, when I had British colleagues, it would kind of play a class thing that I was just a low-life American or whatever else. I would say, well, so what? I'm proud of the fact my relatives were kicked out of England, and I don't need that. So again, it's just a matter of understanding where people are coming from. And that's usually based on personal prejudice, just because people want to categorize people different ways, okay? But again, we come down to what's objectively true or subjectively true. There's objectively true that we've been created in God's image, everybody. And it doesn't matter where we're from. Now, many of you are Christians, many of you might not be, okay? Many of you may be nominal, okay? I became a Christian when I was 15, so I've always been one since then, okay? So I have a certain belief that the Bible is truly the word of God to be depended on for doctrine, historical things, etc. else. But I also have a perspective on it that it's designed to be read and understood by general public. Okay, and if you go too far deep into it, like coming up with 4004 BC, that's going too far, because that's reading into the scripture what isn't there. So again, it's just a matter of understanding how these things work together, understanding how it all fits. So again, we got a situation here where they have this. So back to the slides. Those of you who were listening over there on video, did you hear my little lecture? Did I speak loud enough so you heard me?
Yeah, I heard you.
Okay, good, wonderful.
Yes.
Any questions, anybody?
I'm good.
Okay, thank you. All right, now, one of the things about measurements, and this has to do with how things are defined. I talked last time about the cubit. What is the definition of the cubit? What did I say on Monday? What's the definition of the cubit? Finger to the face. It's variable. It depends on the person, the age, etc. else, okay? And So it's about 18 inches. Okay, but then you have the foot, the yard, and that's called the Old English system. Okay, the foot, the yard, other things like that. Why is the foot useful?
You can measure it like without a tool.
Yeah, you can just use your feet, okay? It's based on an adult male, but a younger female, this is fine. Okay, you can get a general understanding of it. It's not very accurate when you use that, but then it's broken up into 12 inches. Okay, the yard is 3 feet. The mile is 5,280 feet. Now, if you do any research into any of those, okay, if you do any research into any of those things, the mile, feet, and everything, okay, basically you've got a series of things related to this that is kind of goes to, you have feet, inches, whatever. Different countries have different standards. So a foot to somebody in the UK or the US makes sense because we took our feet from the British system, the old British system, okay? But it isn't very useful to people from China or Kazakhstan or other places as they've grown up. They all have their own measurements, okay? So basically one of the values of the Bible here is the whole aspect of cubit is any Bible reader, whether they're from China or whatever else, can understand what a cubit is and then base it on their own knowledge to see how big the ark was, so to speak. So in a way, it's kind of neat how these kinds of things fit in here. But basically, there was a need for an objective standard. Now, what do you notice about the foot? How many inches over there? Does that make sense? No, not really. 3 feet to a yard, and then you got a fathom, which is 6 feet. And some of these things have, a yard is the distance of a typical adult stride. So someone would measure off land that way. A fathom is based on certain number of knots on a rope for an anchor. So they had fathoms, this is about 6 feet. Okay, miles had its own history, but basically that isn't very useful on an international scale. So what they came up with, what they came up with here was the whole point of international measurements, fundamental SI units of measurement. Okay, and so basically the first thing to come up with is one for mass. And mass is a quantity of matter. It is a number. 1, 2, 3, 4. And for chemistry, it's based on 1 atomic mass unit. And you've got to come down with a standard as to how you define 1. So for chemistry, they came up with 1 atomic mass unit, which is equivalent of the mass of 1 proton. So essentially, everything starts off based on the proton is defined as being 1 regarding kilograms or other things like that, okay? So the quantity of matter and the standard is the gram, okay? Here it says it's the kilogram. But what is a kilo? 1,000. So it really isn't the standard. The kilogram isn't the standard. The gram is. So essentially that's important to understand. The gram is the standard. But the kilogram is like 2.2 pounds. It's a little easier to hold in your hand, okay? So that's why fundamentally it's considered the fundamental SI unit. So they base, like, for example, 100 kilograms is 220 pounds. Well, they measure with kilograms too, okay? Then the meter was defined as the next one, okay? The meter is the next one here. Okay, and essentially that is abbreviated M. Why? Because it's just the first letter. Okay, now I used before the foot and the yard. What was the purpose of them switching to the meter? Well, it just comes from the definition, system and nature. The French didn't like the yard or the feet, so they came up with their own and just defined a meter. And the definition of a meter is the length of a platinum bar at some museum in Paris, originally. That was the way it was defined, okay? You gotta have some standard. The kilogram, there's a standard kilogram someplace in Paris also. It's some standard system or whatever else. So everything is based on that. But then as years have gone by, things have gotten more and more precise over the years so that basically you have these. Temperature, we go back to temperature here with it. The British system came up with Fahrenheit. A guy by the name of Fahrenheit came up with it. It's called Fahrenheit. And basically he started off with the number 32 being freezing point of water and the number 212 being boiling point. Now, why did they use water? This is where people hear my accent. Why did they use water? Because everybody knows what it is, okay? It's very logical. Everybody knows what ice is, so the freezing point was given that. Then 212. I don't remember where the 32 and where they came up with the defined number 1 or whatever else. But Dr. Fahrenheit came up with that, okay? But then the temperature came up with the whole concept of Celsius. This is another guy who decided to define the freezing point being 100, 0, and the boiling point of water being 100. What's the value of using 1, 0 to 100? Well, it's based on base 10. 1 through 10, you have 10 fingers. Then it goes through there, so basically it's that. But one of the things that was interesting was I was working in Kazakhstan, Iraq, and the afternoon thing was like 100 degrees Fahrenheit. That sounds hot. But if you were to ask them what is the temperature, they would say 38 degrees. Does that really sound hot to you? No. Okay, so I like to use Fahrenheit over there. And if one of my students asked what the temperature was, I would say, oh, it's about 100. And then they'd have to do the translation themselves. Well, about distance and other things like that, regarding that, why do you suppose the United States still uses the mile instead of the kilometer? Any ideas?
It's what we're used to.
Yeah, well, we're used to, but we're a bigger country than Europe is, okay? And it's more practical to say 4,000 miles to California, okay, instead of 6,000 kilometers. What's the point of changing it if it works? So basically, as the system in nature now, the Americans and the US government even decided to keep what was useful and get the rest behind. But when I was growing up, you would get half-gallon bottles or gallon, you could still get gallons of milk, but half-gallon bottles of milk or whatever else. But now you've got 2-liter bottles. Well, why do they go with 2 liters versus 2 quarts? Well, the thing that's interesting about it is a liter is about a quart. So they just came up with a slightly different version, so it didn't really matter. But the point is they can have the machinery to build them things with the other unit. And so a device built to make a blow molder built to do 2-liter bottles, built and designed in the US, could be sold in France because it met the same specifications. So in some respects, this whole concept of a system of measurements is important, okay? So Kelvin comes from, and this was another guy, because basically for most of the last 300-400 years, 0 to 100 is only what normal people mattered. But then as you got into dry ice and other things like that, then things got down to be -40 and other things like that with very, very cold. And so what they came up with was the whole concept of kelvins. okay? And kelvins has a term called absolute zero. Okay, and absolute zero is minus 273.15 Celsius. So that is given 0K. And so essentially the freezing point there is 273.15 kelvins. And then this is 373.15. 0K is when all molecular motion stops. In other words, you can't get below zero on the temperature scale. It's not possible because everything is solid. Nothing you got sort of that because it's a matter of energy that's in the system. So essentially here we have these associated with this. So essentially it started off as Fahrenheit, then it went to Celsius, then it went to kelvins. So essentially you have the 273.15 K is 0 Celsius, okay? And then the amount of substance was defined as the mole, okay? And the mole is 6.023 times 10 to the 23rd anything. And I'll just use atoms as the example. That is 1 mole. And we'll learn later that 1 mole of water, H2O, is 18 grams, which is easy to measure, okay? So the mole is a defined term, again, when we're dealing with this as well, okay? And then this time is seconds, okay? And there are different things of time associated with this as well. Day, year, day, 24 hours. So you have hours, minutes, and then seconds. And so a year would be 364, 5.25 days. 24 hours in 1 day, 60 minutes in an hour, 60 seconds in a minute. Now, why did they go down to seconds is the thing. Well, when you got very precise devices and you can use exponential notation, seconds works. Because then you just put this exponential notation in there. Like 15 times, no, 1.5 times 10 to the 10th seconds or something like that. That has some usefulness, okay? But when you're just talking about 5 hours, there's a reason we haven't got rid of hours and minutes and such like that. It's useful. So this is important things. And then electrical current and all other units are derived from that. Common prefixes, and what I'd like you to learn between now and the quiz is tera, giga, mega, kilo, deci, centa, and milli. And then micro, which is 10 to the minus 6, and then nano, which is 10 to the minus 9 nano. So the ones I'm highlighting, those are the ones you need to learn for chemistry. And basically they go in front of the different things. The reason we have tera now, when I was in college and I was your age, we didn't have tera at all. But believe it or not, there's like 2 terabyte hard drives out there now. So it's useful for you guys to know it, okay? The best we could do is giga or mega, yes.
For the quiz, we need to know like what power it is to it, or
Sure, sure, just in general and what it is. And I'll like ask you what a kilo is or other things like that, okay? So just general kinds of things like that. Okay, and then prefixes associated with this. So essentially, micro is the next one, nano, and then pico Don't worry about that, or femto. The only people who have to worry about that are physicists. But nano is kind of important just because it's in the vernacular today as well. Mass and its measurement, and we will talk about that on Thursday. Any questions? Those of you listening on video, any questions from you folks?
Are you going to have the slideshows on Brightspace?
Yes, the PowerPoint with my writing on it will be put up on Brightspace. It's already there, and it will say with notes next to the hard one. My apologies for the handwriting, and the recording of this will also be on Brightspace for you too.
Okay, thank you.
Any other questions? Yes. Huh? I'll let you know, because I'm still deciding regarding how I'm going to do it. But basically, for the group that's here now, yeah, you'll come in at about 7 o'clock for about a half hour, or maybe we can arrange another time. Yes. Well, basically, we're going to alternate. So Thursday, tomorrow, you'll be virtual. Monday, you'll be here. And then I'll just alternate days, except for test days. But no, we'll just keep the alternation going on. That's what I set up. But if you're sick or something like that, or you can't come, you're welcome to do it virtually. And what I'm hoping to do is that if people find they like the virtual better, we could just routinely do that during the semester. And that means the more people that want to interact in the classroom can come. We will get a camera here and whatever else to be able to have it fully over this instead of using my laptop, so it'll look better than this. Yes, you had a question.
Volleyball has practice at 7 o'clock or till 7 o'clock?
I'll figure out another time.
Okay.
What time is good for, does anything happen at 5 p.m.?
We have practice then as well. Ours is from 4 to 7:30.
All right, so if we have quizzes or tests, we'll do it at 8. And the quiz will just be a half hour, and it'll usually be on the same day that the other people take it at the same time. And then when we have a test, we'll use a big classroom where everybody can come together.
And do we take the quiz in here?
Yeah.
Okay.
Yeah. And it's just written, and it's just the way to make sure you're all things.
Okay.
Any questions about how it's going to work? Now, hopefully you can hear me better because I'm using this thing. So that's the. Now, I will have office hours, and now that I know how Zoom works, I'm gonna set up the office hours from 12:15 to 1:15. Will be at Zoom. Also have that open, so just show up, and then you can say something, and I'll notice you. But I'll be in my office between 12 and 1:15, either in person or via Zoom. Okay. So I will put an announcement and send it out to email regarding homework problems in chapter 1 of your textbook for tomorrow and next week. Okay. All right. Have a good day. Thank you. Thank you all, everyone. I hope it went well for you there. Did it go okay?
Yeah. Dr.
Wonderful. Yes, this will be posted up on the up in the course materials on Brightspace.
Okay, so do we have our quiz in class on Thursday?
Yeah, tomorrow you'll be coming in person, and the quiz will be the last 20 minutes or something. So yes, it'll be in class, but the others will come at 8 o'clock.
Okay, gotcha.
Very good. Thank you. Bye.
Bye.